Hi everyone. I wanted to talk to you about solving using trig identities. We talked about simplifying, where we just get one side but not necessarily an equal sign and all of that. And we talked about verifying, where we take one of the sides and we take it all the way through the steps to make it look like the other one, but we never touch both. Well, for solving, we do work with both sides. Our goal is to combine them on one side. So combining them means, well, I'll take one side and move it towards the other one. So I'll show you an example here. So I am solving for x. I want to isolate x. So in that case, I'm combining x. So I will take that sine x over here and negative sine x, and I will move it to the other side by adding it. So now sine x plus sine x is 2 sine x. Please don't get confused and say it's sine squared x. I see that error all the time. We're not multiplying, we're adding. X times x is x squared. But x plus x is 2x. Similarly with sine x, it's a function, so it's not x necessarily, but it has the same rules. So I'll get 2 sine x plus root 2 equals 0, because negative sine x plus sine x will go away. Well, I'm not remotely close to being done because, well, I need to solve for x. So that means I want to isolate it. So now I'll move stuff away from x. Well, first you combine, and then you start isolating. So I'll subtract the root 2 from both sides. I'll get 2 sine x equals negative root 2. Then I want to divide by 2 on both sides. Why am I dividing by 2? Because if I look closely here, that 2 is multiplied to sine. To break it up, I need to divide. 2 sine x means 2 times sine x, because when we added, we got that 2. So I'm dividing to break the multiplication. Well, now I have sine x equals negative root 2 over 2. Well, the question is, did I finish solving? And the answer is no. I need to isolate x. I need to take it all the way till I figure out what x is. To do that, I need to ask myself, what does x represent? So I would have an idea if my answer is true or incorrect. X represents an angle. An input for a function is an angle and the output is a ratio. So negative root 2 over 2 is a ratio, and this is an angle. Well, how can I solve for an angle? I need to arcsine both sides, right? So let's see how this works. Sine x equals negative root 2 over 2. Which triangle is that? It is a special triangle. Well, I need to think. Before I rationalize and get negative root 2 over 2, that was negative 1 over root 2 originally. So that tells me the hypotenuse is root 2. Yes, after we rationalized, we got this, but you always need to refer back and think, which triangle am I in? Well, I am in a 45, 45, 90 triangle. This is 1, and this is root 2. So the angle is 45. Well, we want to get used to writing our answers in radians. So my angle is pi over 4. Well, that's in quadrant 1. Let's say I want to ask you for your answers between 0 and 2 pi. If I'm asking you for your answer between 0 and 2 pi, then you have two answers because sine is negative in two places. Since it's negative right here, I know that this is not my angle. This is my reference angle. So I'll use a dash like that to represent that this is not x, but I'm using pi over 4 to figure out my x. This is x prime or theta prime if we're using theta. It's just the reference angle. So let's see, if I want to put my angle right here based on this sign in the quadrants where sine is negative, where would I put it? Yes, quadrant 3 and quadrant 4, because all students, that means here everything is positive and sine is positive. All students take calculus. That refers to the positives only. Alright, let's see. Alright, so if I look at my triangles, my pi over 4 triangles in quadrant 3 and 4, where sine is negative, I will see that I can come up with an answer for this hypotenuse right here, or this terminal side. If I want to put my angle in standard form, this is 4 pi over 4 right there, because that's half rotation is pi. So pi over 4 more, that's 5 pi over 4. 4 plus 1 more. Now, right here in the fourth quadrant, if I want to also put my angle in standard position, then what is that one? Well, that's 8 pi over 4 right here at 2 pi, because 8 pi over 4 would give me 2 pi right there. Now, what's my angle right there? Well, it's one less, 7 pi over 4. So my answers for x is 5 pi over 4 and also 7 pi over 4, and that's between 0 and 2 pi. Well, what if instead of 0 and 2 pi, I asked you to do something like that? If I asked you, let's get the answers for all real solutions. This right here, this symbol right here means all answers for x. All answers for x. In that case, I need to think, well, if I add another rotation, I can get to that angle. Another rotation, I can get to that angle. So if I keep adding 2 pi's, which is one full rotation, the angle will repeat. And we saw that in our graphs, in the sine cosine graph and cosine graphs, like the tsunami problem that we did in class. So that's why it will keep repeating every 2 pi. That's your answer. Hope that helps. Thanks.